Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic that is 5 terminologies with respect to graph, guys. So we'll be discussing about what is a walk, okay, trial, circuit, path, cycle. So these are the 5 different terminologies which we'll be learning in this particular lecture, guys. Okay, so the main reason why we are learning this is so these are some terminologies which are going to be used in Hamiltonian graphs and Euler graph definitions, guys. So to understand those definitions, you need to have some idea about these things. So even without idea of this terminology also you can understand them, but in examination if they give a question like among all these four, which of the following is a walk, you need to identify it. So that is the reason why this is mandatory to learn, guys. These are just 5 small definitions and I'll be teaching you within around 10 minutes maximum. That's it. It will be really easy, so don't worry. Okay, yes. So first of all, let us start. Walk. A walk is defined as a finite alternating sequences of vertex and edges beginning and ending with the same vertex. So that is nothing but a walk, guys. Okay, so what is step 1, guys? So it should start with vertex, it should end with vertex, and it should alternately move from vertex edge, vertex edge, vertex edge, vertex edge, and end with vertex. That is the concept of walk. Okay, so if you observe this particular diagram, so what is a walk, guys? So V1, E1, V2, E3, V5, E4, V1. So this is a walk, right? Yes. So in the same way, this is also a walk. In the same way, this is not a walk. V1, E1, V2, E2, V3, E8, V6. Starting and ending should be same, they told. But it's not. So it is not a walk. Got it? Yes. So here I wrote some examples. So V1, V6, okay, and to be clear, one more thing, guys, okay, so if the starting and ending vertex are different, if they are different, it is called as open walk, guys. I think I did not write it, but for understanding it was really important. Okay, yes, so if it is open, means if the starting and ending vertexes are different, different, means it is open walk. If they are same, it is called as closed walk. Got it? Yes, so that's important to learn, guys, because in the next definitions you will use this terminology like what is open walk and what is closed walk. Okay, yes, so it is, the only concept is it is a vertex edge pairs. Okay, vertex edge, vertex edge, vertex edge, and end with vertex, start and end with vertex. Got it? Yes. Okay, so here we wrote an example. So V1, E1, V2, E2, V3, E8, V6. So this is a walk. Similarly, V1, E4, V5, E6, V5, E7. Here there is no vertex, right? So what did I say? It should start and end with vertex. So but here it is not ending, so it is not a walk. Okay, so if started and ended with okay, so I wrote here. So if started and ended with the same vertex, it is a clause called as closed walk. So I took this as an example, guys. Okay, and similarly, if it is not having same vertex at start and end, it is called as open walk. Got it? Yes. So length of the walk is a number of edges. So basically, if some question they asked what is the length of this particular walk, so it is a 1, 2, 3. So the length is a 3. Got it? Yeah. Yes. Okay. So it's quite easy, right? Yes. Okay. So now I hope everyone got a clear idea about a walk, right? So what is a walk, guys? It is just an alternating sequence of vertex edge, vertex edge, vertex edge. It should start and end with the vertex. That's the only thing here. Okay. Yes. Okay. So now let us go through the next definition. That is trial and circuit, guys. Okay, so I think now you are getting some idea, right? So what is a trial? So trial will talk about open walk, guys. Okay, and circuit something like circle, so it is going to work with the closed walk. Okay, so a trial is an open walk with no edge repetition. So in trial and circuit we will work with edges, we will work with the edges, guys. Okay, in circuit is a closed walk. That is the only difference. Closed walk with no edge repetition. Got it? Yes. Just give me a second. Okay. Sorry for that, guys. Okay. So let us revise. So what is a trial, guys? Trial is nothing but an open walk with no edge repetition. Circuit is nothing but closed walk with no edge repetition. That's it. Okay. Yes. So now let us start, guys. So assume that this is the graph given and this is the series given. So step 1 is what, guys? So first identify what type of walk is there. First of all, check whether it is a walk or not. So it is starting with vertex and ending with vertex and vertex edge, vertex edge, vertex edge, vertex edge, vertex. Hence it is a walk and it is a starting and ending with different vertices. So it is an open walk, right? Yes. Similarly, if it is open walk, can it be Okay, can it be a circuit, guys? No. With that conclusion, you can directly strike it off and compare. So is there any edge repeated? So if you observe, E3 is repeated 3 times. Is that really true, guys? V1, V2, sorry, V1, E1, V2, E3, V5, okay, just give me a second, V5, E3, V2, again E3, again V2, okay, so I think if I write E5, V5, it will be making more sense, right? Yes, okay, so it is a nothing, but it is nothing because it's not a trial, it's not a circuit because the edge is repeated right here, yes. So if we take one more example, so this is some other graph, V1, E1, V2, E3, V5, E3, V2, E2, V3, E5, V5, E4, V1. So it is a starting and ending with the same vertex. Hence it is a closed walk. So it cannot be trial. Okay. Can it be a circuit, guys? If you observe here, 2 edges are repeated, right? E3 is repeated and that's it. Yes. So E3 is repeated 2 times. So indirectly, hence it could not be circuit also. Hence it is not a circuit nor trial. So coming on to the last one, that is a E1, E2, V2, E3, V5, E5, V2, E7, E4, sorry, V4, E6, V5, E4, V1. So basically it started here, it rotated completely and came back, guys. So if you observe, it is a closed walk, okay? And if you observe, there is no chance of edge repetition, right? Yes. Hence it is a circuit. So this is the concept of a trial and circuit, guys. So now you got an idea, right? Yes. So now the continuation, it continues. So now the next 2 pair are path and circuit. Okay, so path is an path. If, again from observation you can say, so path is something open, circuit is something closed. Okay, so basically path is nothing but a trial in which no vertex repeated more than once. And similarly circuit is nothing but, cycle is nothing but a circuit in which terminal vertices as an internal vertex and non-internal vertices is repeated called cycle. Okay, so basically what these 2 definitions are saying is, so path is a nothing but a trial without repetition of vertices. Similarly, cycle is a circuit without repetition of vertices other than the terminal. So basically starting and ending should be same, that's it. Anything other than that is not allowed. Okay. Yes. So now I think everyone understood the chain, right? So why did I start at walk? Why did I teach a trial and circuit then? And at the end we came to path and circuit. Got it? Yes. So now let us go through the examples. Okay. So basically this is the diagram given. V2, E2, V3, E5, V5, E3, V2. So it is circular. It started and ended at the same vertex and it is a vertex edge, vertex ending pair. That is a closed walk. Yes. Is there any edge repeated? No. Is there any vertex repeated? No. Hence, first of all, it becomes a circuit, then it becomes a cycle. Done. Got it? Yes. Similarly, this V1, E1, V2, E3, V5, E5, V3, E7, V4. So basically, it started at here, it ended at here. So it is an open walk. Is there any edge repetition? No. Is there any vertex repetition? No. Hence, it is a trial and it is a path. Got it? Yes. So these terminology are really easy, guys, but there is a potential chance of getting confused also. So that is the reason why please concentrate while reading, guys. Okay. Yes. Okay. So now I hope everyone got a clear idea about these 5 terminologies, right? So walk is nothing but alternate vertex edge pair and ending with vertex. Trial is nothing but an open walk with no edge repetition. Circuit is nothing but closed walk with no edge repetition. Path is nothing but a trial with no vertex repetition, and circuit is nothing but cycle is nothing but a circuit without without vertex repetition other than the starting and ending. Got it? Yes. Okay. So now I hope everyone got some basic idea, right? Yes. So let us go through a small concept that is a connected graphs, guys. So when can we say a particular graph is connected, guys? So if the graph is given, we can easily decide, right? Yes. So if you ask me, just give me a second, I'll be taking a piece of paper. Okay. Yes. So assume that this is a graph which I give, and I am saying this is the only graph with the 3 vertices. So at that time everyone will be saying it is connected as there is no other disconnected component. But if I give like this, these 2 are a single graph, I am saying. So at that time these 2 are disconnected, right? Yes. So how we are saying they are disconnected? So by observation we can say. But what if the examiner does not want to give us the definition or does not want to give us a diagram? So at that time how we can identify is so let us go through the theory first. So what is connected graph, guys? So there should be connection in between every vertex to vertex, right? So in this diagram, if you observe, so you extend it how much you want, you can extend, guys. Okay, yes. So you take any two vertex, there will be a path. So just with that understanding, you can say that this is a connected graph. Got it? Yes. So a graph is said to be connected if there is at least one path between every pair of vertices in the graph G. Okay. So if there are n vertices, okay. So assume that, let us take a small case, guys. Okay. Yes. So assume that there are five vertices, guys. 1, 2, 3, 4, 5. Okay. So there are a total of 5 vertices, assume in that way. Okay, so if I want to make it disconnected, okay, so if I want to make it disconnected, what I will do, guys, I will leave one vertex. I will assume that that vertex is not even there, and I will work with everyone, right? Yes. So let me assume that this center vertex is not there. So I will connect all these guys in this way. Yes. So basically, how many edges have been occupied, guys? 1, 2, 3, 4, 5. So for until 5 vertices, 5 edges, there is no issue. Okay, I think the ink is done. Okay. So up to 5 vertices, there is no issue, right? Yes. So if I want to add one more edge here, okay, up to 5 edges, there is no issue. So I added 1, 2, 3, 4, and 5. In total, I added 5 edges without any issue. So now if I want to add one more edge, where I can add, guys, so almost all combinations are done. So basically now I need to connect this guy with everyone. So the minimum number of edges to make a graph disconnected is 5 right here. Yes. Similarly, if I want to connect it, the minimum will be 6, right? Yes. If I add just one edge, one edge, it will be connected. Got it? Yes. Okay. So now I hope everyone got some basic idea, right? Yes. Okay, so if you want some formulas for this, so basically if there are n vertices, so what are the count of vertices, guys? 1, 2, 3, 4, and 5. So if there are n vertices, the minimum best case will be just with the n minus 1 edges we are able to connect. So basically if there are 5 vertices, assuming that the best case I am saying, so I will add 1 here, 2 here, 3 here, and 4 here. Just with 4 connections, I was able to establish it, make it into a connected graph. Okay. In the worst case, up to how much it can go, guys? It can go up to n minus 1 into n minus 2 by 2, guys. Up to this extent it could go. So if you take this same example, so here the vertices are how many? 1, 2, 3, 4, 5. So it is a nothing but 4 into 3 by 2. That is a nothing but 3 2s are 6. So if you recall, 6 is the minimum number, right? Yes. Okay, so now I hope everyone got some basic idea, right? Yes. Okay, so now I hope everyone got a clear idea. So in the next lecture, let us continue with the Euler graph, guys. Okay, so the basics which you have learned, like open walk, closed walk, and all those things will be again used in the Euler graph. So that is the reason why I discussed this concept first. Okay, yes. So in the next lecture, let us continue with the Euler graph. Thank you. Thanks for watching. Like, share, and subscribe for more awesome videos like this. Thank you.